Hello.
Sir, okay, sir. Continue, Mani.
Madla? Okay.
Yes.
Good morning to all.
Good morning, sir.
Good morning, sir.
Okay. Welcome to the third online class on the basics of computer networks. Are you able to see my screen?
Yes, sir.
Yes, sir. Yes,
Yes, sir.
Okay. Can you read this particular slide? Hello?
Governing the
Yes,
internet.
sir.
Yes, sir.
Go on your internet.
Governing the internet. Governing the internet. Who controls the internet basically?
Government.
Is there any government or any organization or any government, for example, whether Indian government controls the internet or US government controls the internet or any single country is controlling the internet?
No, sir.
No, right?
No, sir.
No,
It's
no
not controlled by
single
anyone.
government, no single authority, but many different volunteer authorities and different society like internet society can work for the purpose of the internet to promote information exchange, right, to bring standards and allocation of resources and addresses. For example, IANA works for addressing, right? IANA stands for
Internet assigned number authority.
number authority. Very good. IANA. So like this we have various authorities, different volunteer organization like IETF, Internet Engineering Task Force, who discuss with respect to the internet operations and technical problems. So this class also will continue with some more basics of the computer networks which are important. We know how internet works, and in our internal test or in some point of time, if somebody asks you regarding the architecture of the internet, you should be able to write. You can follow one such architecture. There are different architecture images available. This one such architecture which I have taken from computerhowstuffworks.com. How internet works basically, what is its architecture is shown here. So can you find this, see this architecture?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
The local internet service provider provides the internet, right? And suppose if we are a university working as a dorm user, what is dorm user? Dormitory user. A student or a professor in a university setup. Okay, so we are here. You're able to identify the position in this architecture. This is a high level architecture of how internet works in this dorm users. I am showing here, say department local area network, called it as a dorm LAN in general. This university network here, and this is the office users, office LAN. Okay, and you can see here other universities and other web sites working, google.com for example, and this is safe, whitehouse.government, stanford.edu, like this. Are you able to understand this?
Yes, sir.
Okay.
Yes, sir.
So between the internet and local area network, do we have any other devices which are connecting?
Repeaters. And nothing else.
Huh? In this architecture, you are able to look at this architecture, right? This is the
Yes, sir.
internet. This is our network. In between this internet, in this internet architecture, between our computer to the internet, you have something in between. What is that?
Firewall, sir.
Firewall.
Firewall, sir.
Firewalls.
Is it? Firewall. What is this R stands for?
To
Router.
router.
Router. Router. We generally are recommended to pronounce it as a router. Let us not pronounce it as a root because it's like a plant root. Router. Okay, this is the overall high level architecture of the internet. So, internet service provider, local ISP, here the internet, this internet is being used by many others, okay, like government.com and edu, .gov, okay, .com and .edu they are using. And here the university is using the internet. And in between this internet and the university network, you are finding firewall and router. So here what you are finding here, what is this?
Wireless.
Wireless,
and,
wireless small subnet. Okay. So I hope you got some idea of how you are having the internet connections. How is the high level architecture? Is it right?
yes,
You
sir.
were able to
Yes, sir.
picturize the internet working?
Yes, sir. We are able to picturize it.
Okay, okay, thank you. Now, some more basics because generally we in our practicals we have distance vector routing algorithm. Okay, we talk about different routing algorithms in the syllabus, and we talk about access points. So I thought it is required to know basically what is an access point and router. These two are same or different? Hello?
Yes, sir.
Ah. These two are same or different?
Different.
Different,
Different.
sir.
Yes, sir.
Access point is different from router.
Router.
What router will do actually? There are two primary functions for the router. One is to connect
connects the
multiple
computer.
computers, phones, tablets, and other devices to form a manageable local area network. It connects different devices in a LAN. It provides internet access to all of the compatible devices that are connected to the router. Okay? A local
Okay,
area
sir.
network can be set up by simply deploying a router and connecting one or several devices to it. Modern routers allows user to connect devices both via Ethernet cable and using Wi-Fi. Okay, recent routers will enable devices to connect both using Ethernet cable and Wi-Fi. You got what is a router?
Yes, sir. We have got it.
It connects multiple computers or other devices in a local area network, and it provides internet access to the devices which are connected to the router. You can simply set up a local area network by deploying a router and connecting one or more several devices to it, right?
Yes,
However,
sir.
in order for the router to distribute and deliver data access within the local area network, it must be connected to an internet service provider. via an Ethernet cable. These are very basics. I think you know, just to refresh your understanding to start the syllabus. Then what are the main differences between the router and the wireless access point? The router acts as a hub that sets up local area network and manages all devices communication in it. Right? An access point,
sir.
on the other hand, within the local area network provides another location for devices to connect from and enables more devices to be on the network. Wireless access point. Okay, wireless access point extends the connectivity to other devices. Wireless router can function as access point. So you can think of even access points also to be part of the wireless router. But not all access points can work as routers. So you have to carefully understand this. So if you go to a market or if you go to a shop and ask for wireless access point and routers, he may tell you that this is a recent router. It also consists of the wireless access point. But the reverse, the vice versa is not true most of the time, because all access point cannot, okay, all access point cannot work as routers. While routers manage local area networks, communicate with outside network system, acquire, distribute and dispatch data in multiple directions. Okay?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
Have to respond, otherwise I think you are sleeping. I will not allow you to sleep, but still you don't try. Respond. You keep responding questions, you will remember the points.
Yes, sir.
Question is, wireless routers can work as access points. Yes or no?
Yes, sir. They access the access point.
But all access points
Cannot work as a router.
Cannot work as a
work as
router.
routers. This is the important point that you have to understand and remember. An access point is a wireless network device that acts as a portal for devices to connect to the local area network. By using the access point, you can extend the wireless coverage of an existing network for increasing the number of users that can connect to it. Correct? You got this? For what purpose we are having wireless access point? To extend the wireless coverage,
Yes, sir.
to increase the number of users. That's why we'll be using the access points. So you can see here, we use generally a high-speed Ethernet cable from a router to an access point. So router, its coverage area has to be extended using the access point. Then there is some connection required. How do we connect? Generally, high-speed Ethernet cable is used to connect router from a router to an access point, and which transforms the wired signal into a wireless one. Which one transfers? Transforms the wired signal into a wireless one.
A high-speed Ethernet cable.
Ethernet cable.
Wireless connectivity is typically the only available option for access points, establishing links with the end devices using Wi-Fi. These are some of the important points. Now the question is, which one is better? Whether we have to use the router or the wireless access points?
Wireless, sir.
Which one is better?
Wireless.
Wireless.
Wireless,
No,
wireless.
wireless router, wireless access point. Say, let us say wireless router and wireless access point. Which one is better?
Wireless access
I
point.
think wireless router, sir.
If you are
Wireless router I
having
prefer.
very small number of devices to connected, and if the radio range coverage of the router is just enough to have the small network, then you will be using the wireless router. If you are having extended coverage to be done, then you have to use wireless router as well as access points, both. Okay.
Yes, sir.
So how you are connected to now?
Wireless access point.
One second. You are able to listen for this?
No, sir.
Now, a lot of
No?
people think that these
sir.
two devices are the same thing, but even though they do look similar and they do similar things, they are in fact different.
Yes, sir.
So let's first talk about a Wi-Fi router. Now, almost everyone who has an internet connection in their home would have a Wi-Fi router, whether that Wi-Fi router is a separate device or if it's built into their modem. A Wi-Fi router is what allows multiple wired and wireless devices to join together in a local area network. It'll broadcast a Wi-Fi signal so that wireless devices can connect to it, and it'll also have a built-in switch with several network ports so that wired devices can connect to it using Ethernet cables. And then that Wi-Fi router will directly connect to a modem to give those devices internet access. Wi-Fi routers are mainly used in homes and small offices. So here we have a typical home where a couple of desktops are connected to the Wi-Fi router's built-in switch using cables. And we also have laptops and tablets that are connected wirelessly to the router. So now let's talk about a wireless access point. A wireless AP relays data between a wired network and wireless devices. It's basically a wireless hub that's used by wireless devices to connect to an existing wired network. A wireless AP connects directly to an organization's router, where the router is then connected directly to a modem, which gives the wireless devices access to the internet. Now, wireless access points are primarily used by medium to large organizations. And typically, an organization will have multiple access points to make sure it covers the entire building. So, for example, here we have a medium-sized office. And this office has desktop computers, laptops, and tablets. So the desktop computers will connect to the organization's router using Ethernet cables. But in order for the wireless laptops and tablets to connect to the network, this office is going to use wireless access points. So the access points are going to be placed in strategic places, and each of them will connect to the router using an Ethernet cable. Then once that is done, they will all broadcast a Wi-Fi signal so that the laptops and tablets can connect wirelessly and join this network. So now all the desktop computers and wireless devices are joined together in one network. And that one network is managed by one single router. And because wireless access points are managed by a single router, that is one of the main reasons why larger organizations use wireless access points instead of Wi-Fi routers. Now, in reality, this office here can use Wi-Fi routers instead of wireless APs, and it would work just fine. But the problem with using Wi-Fi routers instead of wireless APs is manageability. If the network administrator wanted to manage this network and make certain changes, you would have to log into each Wi-Fi router to make that change. And that could be a hassle and time consuming, especially if there were a lot of Wi-Fi routers. But if this office was using wireless access points instead, then all the management and all the changes in the configuration would be done by this single router, which makes managing a network a lot easier. So all the wireless devices can be treated as a single subnet instead of being treated as multiple subnets if Wi-Fi routers were used. Another difference between these is how devices are able to connect to them. Wireless access points are strictly for wireless devices to connect to, whereas Wi-Fi routers are able to accept connections from both wireless devices and wired devices. Because in addition to having a Wi-Fi antenna, Wi-Fi routers will also have a built-in switch to accept Ethernet cable connections. Another difference is a firewall. Wireless access points don't have a firewall, while Wi-Fi routers will have a firewall. Wi-Fi routers will also have a built-in DHCP service. A DHCP service is what automatically assigns IP addresses to devices that are connected to it. So when devices connect to a Wi-Fi router, its built-in DHCP service will directly assign those devices an IP address. But since wireless APs don't have a DHCP service, the devices that are connected to it will get its IP address from the organization's router. So once a device connects to the wireless AP, the router will send the IP through the wireless access point and then to the device. And another difference is that Wi-Fi routers will have a WAN port or internet port. A WAN or internet port is where you would plug in a network cable coming in from your modem. And this is what gives your Wi-Fi router an internet connection so it can pass it on to other devices, whereas a wireless access point doesn't have a WAN or internet port. So it cannot directly connect to a modem. It has to connect directly to a router instead, and then the router is what connects to a modem. And on a final note, wireless access points are often used to further extend a network's existing wireless signal. So for example, if this home needed to extend its Wi-Fi signal further into this home, you can attach a wireless access point using a network cable to the Wi-Fi router so that distant devices can connect to the Wi-Fi signal.
Hello?
Yes, sir.
Yes, sir.
Are you able to follow the video?
Yes,
Yes,
sir.
sir.
Okay. So can you list out the differences between the router and the wireless access points? What are the differences?
The router can
The
be
pair-
connected to the wired and wireless, but access point can only connect it to the wireless.
Very good, very good. This is one important point. What about firewall?
The firewall is present in the router and not in the wireless.
Very good, very good. And what about WAN port? WAN port, wireless
Only in routers.
only in router, not in wireless access points. Yes, third important difference. The fourth important point.
DHCP is present in routers.
Yes, exactly. Very good. So take this as an assignment, okay? And listen to this video once again at home. And there are some more differences explained. List out all the differences. This may be a one question in your internal test. Difference between wireless access point and the router. Fine. So we'll go to the next basic point, that is local area network. So these are the important things that we require to understand. So we know that LAN basically covers the small geographical area within an office building. and what are the different technologies that we use to connect the local area network?
So the
Technologies to connect the local area network. You heard about Ethernet, right?
yes, sir.
Ethernet
Yes, sir.
technology, token ring technology, and FDDI, fiber distributed data interface. Okay, so remember, LAN covers small geographical area. Technologies used to connect the LAN are Ethernet, token ring, and FDDI. Ethernet is a most commonly used LAN technology. Okay, Ethernet is a most commonly used LAN technology. Many corporation uses the token ring technology as well. And FDDI also many people use. FDDI stands for Fiber Distributed Data Interface. Ethernet or token ring LANs are another LAN technology called ARCnet. That's another technology. Most commonly installed LAN technologies. But ARCnet generally is used, LAN technology used in industrial automation. Industries uses this technology. Okay, so this is an important point with respect to the LAN. So with respect to LAN, LAN covers small geographical area. Technologies used in the LAN are Ethernet, token ring, and FDDI. And Ethernet is the most commonly used technology. Okay, so remember these points. Wide area network. Wide area network is bigger than, okay, wider, this communication is wider than local area network, metropolitan network. The application of an wide area network is not limited to a room or building or specific place. Okay, so wide area network, as the name suggests, symbolizes, its coverage area is wider, communication is wider than local area network, metropolitan area network. Different LAN networks are connected to establish a network which will enable the users of one location to communicate with users present in other location. Internet service providers usually help establish wide area networks. However, many large organizations will be having their own wide area network. How the communication happens in the wide area network? Using circuit switching mechanism. Wide area network uses circuit switching mechanism. Most commonly used physical network nodes are switches, hub, and modem. Okay, switches, hub, and modem are used in the wide area network. You have seen what is a hub, what is a switch, and what is a modem. Okay.
Yes, sir.
So wide area network uses what type of technology for communication?
Ethernet, FDDI, and ring
So
token
that is
ring.
for LAN. That is for LAN. Ethernet, token ring, and FDDI for LAN. For WAN, wide area network, circuit switch network, packet switching network, frame relay or packet relay or cell relay networks. Okay. So please make this as a point. Wide area network, different types of WAN can be established, and these different types of WAN can use leased lines, and they may use circuit switch network, packet switch network, frame, okay, and cell relay. Packet switching is one of the most common type of establishing wide area network. Generally, we use packet switching network. In a packet switching method, a digital network is established. In this method, suitable data blocks are created, and these data blocks are known as packets. Data blocks in packet switching method are called packets. The data travels in the form of varied bit rate. There are two types, constant bit rates and varied bit rate. In WAN, we use varied bit rates. That means data transmission rate may vary. These bits travel in the form of sequence of packets over the network, and their delay is dependent upon the load of traffic over the network. Packet delay depends upon the load of traffic. If traffic is less, if there is a less congestion, packets will move easily, quickly. And X.25 and frame relay are most suitable protocols for this kind of network. X.25 and frame relay. These are communicating protocols used in WAN. Leased lines are the most suitable and quick way to establish a wide area network. Leased lines are also used. So friends, please remember that whatever you said, the Ethernet, token ring, FTDI are the technologies used in LAN for communication to establish the LAN. But for in the WAN, wide area network, we use leased lines, circuit switching network, packet switching network, frame relay, and packet relay. These are the things we use. However, leased lines are generally not preferred due to their expensive nature. Leased lines helps to establish symmetric connection from one point to the other. We know that, but it is always costly. When a network is established using a packet switching method, a user usually receives variable bit rate at its end. Okay, so
Okay, sir.
it puts at the variable bit rate. That means what? The data rate varies. So if the wide area network is to attain the constant bit rate transfer, then cell relay can be used. Cell relay means the data packet is of same size, cell, symmetric. Okay, then cell relay has to be used. In the packet switching method, there is a variable bit rate. If you want to have your wide area network which supports constant bit rate, then we have to use cell relay technology. So in cell relay technology or in this method, data is separated in fixed bits to travel over a network. If you are having variable bit also, the cells are prepared. So sample protocol of this sort can be called ATM. Okay, so these are the some of the basics with respect to the LAN and WAN. So variable bit rate usually user receives if the packet switching methodology is used. If you want to have a WAN with constant bit rate, then cell relay technology can be used. Datagram versus a packet. Datagram versus packet. So most of the time we use the word packet and datagram. What is a packet?
It is a data block.
It's a data block, unit of information, a chunk of information. A packet is some unit of information, some block of information. Okay. What is a frame? What is a frame? Frame is also a block of information, but an Ethernet frame is having a maximum size of 1500 bytes, whereas a packet size varies from 7 to 65,542 bytes. Packet size varies. Okay. Whereas datagram is synonym for packet. Datagram is synonym for packet and used in UDP connection. If the block of data that you are using UDP, then we call it as a
User Datagram
datagram.
protocol.
Datagram. IP datagrams are also referred to as IP packets. IP datagrams are also referred to as IP packet. You can see this packet header. In this source port, destination port, sequence number, acknowledgement number, header length, unused, receiving window, internet checksum, urgent data pointer, options, data, all these things are given. And also here, 6 flags are given: fin flag, sync, reset flag, push flag, acknowledgement flag, urgent flag. Can you guess to which protocol this packet header belongs to? Hello? Hello?
Sir, repeat the
Yes, sir.
question.
So here datagram versus packet. In this slide, you are having this packet header. To which protocol this packet header belongs to is the question. This header
Internet
belongs to,
protocol.
huh? Please repeat. Internet protocol, right?
Yes, sir.
Internet protocol. Fine. So IP protocol, IP packets size varies from 7 to 65,542. If you do not able to remember this 542, at least of the order of 65K you have to remember. Okay, of the order of 65K. Packets and communication. Can you look at this?
Yes, sir.
Frame header, frame data, and frame footer. This frame is used, this term frame data is used on what layer?
Network.
OSI.
Network.
Data link layer. On physical layer and data link layer, you are having this, right? Framing comes in which layer? Data link layer. Framing is the functionality of the data link layer. Raw bits moves on the physical layer. Packet is the term used on the network layer. Segment is the term used on the transport layer. Data is used on the application. Okay, so these are the different terms that you can use. Now, what are datagrams then? Datagram is a basic transfer unit associated with a packet switched network. Okay, datagrams are typically structured in header and payload sections. Datagrams provide connectionless communication. So when it is connectionless communication, the delivery of packets will be of different order. Arrival time taken may vary. significantly. And order of arrival of datagrams need not be guaranteed by the network. So you have to reassemble in order to have a information which is as transmitted, as sent to be at the receiving end. We have to match the datagram received, and this rearrangement of the datagrams received at the receiving end should be same as the sending. Therefore, we'll be having the responsibility of rearranging the datagrams at the receiving end. Okay? Datagram versus packet. We can assume that difference between packets and datagrams are IP protocol types. If the protocol is TCP, it is a packet. If you are using transmission control protocol, it's a packet. On the other hand, if the IP protocol is using UDP, it is called datagram. Okay, so please remember these points. Hello.
Yes, sir.
So
Yes, sir.
Yes,
points
sir. Yes, sir.
understood, followed.
Yes, sir.
Yes, sir.
What is the, so if I use the packet, if the IP protocol uses TCP, then that chunk of information is called as packet or datagram.
Packet.
Packet, sir.
Packet.
Packet, sir.
Yes. If the protocol is UDP, then it is called
Datagram.
datagram. Datagram provides connectionless communications. Yes or no?
Yes, it
Yes,
provides
sir.
connectionless services.
Connectionless. What do you mean by connectionless communication?
Acknowledgement ಎಲ್ಲ ರಿಸೀವ್ ಮಾಡಲ್ಲ ಸರ್, ಡೈರೆಕ್ಟ್ ಡೇಟಾ ಟ್ರಾನ್ಸ್ಫರ್.
Issue ಮಾಡಲ್ಲ ಒಂದು ಇನ್ನೊಂದು. The different paths are used. There is no dedicated path. There is no dedicated path. In connection oriented service, you'll be having a dedicated path till you complete that particular session or communication. The resources are allocated and reserved, and you can use that. Okay, so these are some of the basics. In the next class, we'll continue with these basics. I will take the attendance. 1 second. So please answer your attendance. Sugandhini.
Present, sir.
From Monday you are coming for regular class?
Yes, sir.
Okay. Manish?
Present, sir.
Okay. Shri Vishnu Sharma?
Present, sir.
Akrut?
Yes, sir.
Darshan Kumar?
ಪ್ರೆಸೆಂಟ್ ಸರ್.
So we need to start the lab. Better if you come to the physical classes, direct classes. Anaga?
Present, sir.
Anusha? Anusha? Divya Ram?
Yes, sir. Yes, sir.
Rupak Datta?
Yes, sir.
Shadab Ansari?
Present, sir.
So 11 present. Thank you. So we'll meet
Sir, you
again.
not called my name, sir. Sir, you not called my name.
Kaushik.
Yes, sir. Present, sir.
Yeah, Kaushik. But including you, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 are present. So anybody is left out?
No, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.